Welcome to the RoboJackets TE sessions. In case you've been wondering this whole time, TE stands for Technology Enrichment. My name is Sarah Storer, and yeah, this is our last TE session. So this is our presentation on the control system preview for 2019 from Ignite Robotics that was accepted into the demo for the 2019 WPI library. And this is Tyler Shin. He's going to do a presentation. Yay!
All right. Hi, welcome to the 2019 Control System Preview TE session. That's fascinating. Okay. Hi, my name is Tyler Shin. I am a senior in high school. This is my third year doing FRC, and I am the programming lead for Team 6829 Ignite Robotics. Miriam Morris and I are the veteran programmers on Team 6829 Ignite Robotics. We did the bulk of the testing for the beta program, and we put this presentation together for you guys to share our experience with the beta process and give you some insight in what you should expect for the 2019 control system. This presentation, the slide deck, will be available online at the following URL. So if you want to go back and see these slides again, just go to that link. All right. This presentation will be broken up into 4 sections. We'll be starting off with the application process for beta. What is beta in the first place? How do you get in? How do you apply? Next, we'll be talking about some terminology and concepts that will help clarify the rest of the presentation. After that, I'll be talking about what is actually new in the 2019 control system, what new features can you expect, what new tools and software will you be working with, and we'll be ending the presentation by discussing our 2019 experience specifically and some tips that we want you to know when you're transitioning from 2018 to 2019. All right. Periodically, FRC wants teams to test something that will be present in the upcoming season. This year for 2018, they wanted teams to test out features that were present in the 2019 control system. The way they do this is they announce the beta program sometime in the fall. Teams will submit their applications by late September, and then FRC will review those applications and select 20 to 25 teams per language to participate in the beta program, and the beta testing will take place from mid-October to early December. The important thing to note about beta testing is it does not confer any kind of competitive advantage for teams who choose to participate. There's no information about the upcoming game that is revealed to the teams who participate in the beta program. Really, the only advantage to being a beta team is that you have an opportunity to help out the community and provide feedback to FRC when they request it. So, for every beta program, there are some general responsibilities and expectations that FRC wants you to follow. This is regardless of the year or what you're testing. The first one is the non-disclosure agreement, the NDA. FRC does not want you to divulge or reveal any specific pieces of code or software that they want you to evaluate. Second thing is there's always some kind of beta-specific tasks that I'll get into for us, what we had to do for the next, or during the next slide. But one of the main things, beta-specific tasks we always have to do is provide feedback. This is done in 5 main ways. First of which is regular progress reporting on the beta portal. They also expect us to report any bugs that we encounter during the process, discuss beta issues with FRC and their partners, review any control system documentation that FRC or their partners release, and monitor the beta testing forums to see what other problems teams might be running into. And finally, FRC wants us to support the community. We do this by providing a presentation or briefing to local teams on the new changes. That's what we're doing here today, as well as acting as a local resource if teams have any questions or need help with some of the new features. Because as a beta testing team, you're in a unique position to provide this assistance because you've had this, exposure to what's coming in the next season. Right. So these are the beta-specific tasks we had to do for the 2018 control system. We started off with simply reading the documentation, reading the READMEs, reading all the installation instructions that we needed to follow for the beta testing program. After that, they wanted us to install the software and tools we needed to facilitate the beta program, as well as record the installation times, log any of the problems we encountered, and any of the questions we had during this installation process. After we installed those tools, they wanted us to image the RoboRio with a 2019 image, again, recording the imaging time, how long it took, any issues we encountered, questions, etc. After that, they wanted us to simply deploy boilerplate code to the RoboRio to make sure that our imaging was successful and that we didn't encounter any issues during the deployment. After that, they wanted us to port existing 2018 code to the 2019 system to make sure that the porting process is valid. We didn't encounter any issues with that. And finally, they wanted us to test out new features in the 2019 control system. I'll talk about those in more detail later in the presentation. Now we're going to talk about some terminology and concepts that you may or may not be familiar with. This will help clarify the rest of the presentation, hopefully. First thing we want to talk about is unit testing. So what unit testing is when you you extract individual pieces of your code base out, and then you test them in isolation, and then once you validate that they've worked, you put them back into the code base itself. So an analogy for this would be, let's say you're building a car, you assemble the car, and for some reason the car doesn't work. A car is a pretty complex machine, so you don't really know exactly what went wrong when you built this car. So a better way to approach this would be, let's say you would have each individual subsystem of the car, test out that subsystem. So you have the engine, make sure that works. You have the steering, make sure that works. You have the brakes, make sure that works. Once you verify that all these components are working, you put the car together, and then you know it's a working product. So that's what unit testing is in a nutshell. Motion profiling is a way of pre-planned motion that will result in smooth and predictable movement. An analogy for this, let's say I wanted to go from where I am currently to the door. In my mind, I would plot the path that I would need to take from here to the door, and then I would think about it and see how fast do I have to go to achieve smooth and predictable movement from here to the door. So I would just start walking slowly, accelerate, maintain a constant velocity, and then slow down once I get closer to the door. I wouldn't start running immediately. I would slowly just ramp up, constant speed, then go down. So that's what motion profiling is. Version control is a way of tracking changes to a file or a set of files. Basically what we do is you add or commit changes to a file or a set of files, and that's added to a history. And we're able to access that history at any time for any changes we made at any point in time, as well as revert back to those previous changes if we need to. An example for this, let's say you use Google Docs, you know that on the right-hand side, you can see a version history of the document. That, in a nutshell, is what version control can accomplish, because you can see all those changes you made and revert back to any of those. An IDE, that stands for Integrated Development Environment. That's where we write our code. CTRE stands for Cross the Road Electronics. That is the company that makes the control system components we use in FRC. So they make the power distribution panel, the Talon SRX motor controller, etc. They also make the firmware and the API to control those devices. Build process, okay. Build process is the process in which we take to convert the code we write in an IDE into something that can be executed on a machine. The machine in our case would be the robot. So a build process can have one or more steps. So for example, we have these two fundamental steps, compiling the code and deploying it to the robot. This can be extended to beyond 2 steps. So we can actually inject these intermediate steps if we want to. So let's say I wanted to implement some kind of administrative task. So in between that compiling and deploying, I can, for example, send an email saying the deployment has finished, the build's successful, or something like that. I can also implement policy tasks. So let's say I wrote some unit tests, and when I deploy the code, if those unit tests don't pass, I can automatically fail the build. That would force me to go back in the code, fix it so the tests pass, and then that lets me deploy successfully. So you can implement those kind of intermediate tasks between compiling and deploying for your build process. All right. Now I'm going to talk about the new stuff in 2019 control system. Starting off with Visual Studio Code. So VSCode is the new IDE for 2019 and beyond. Eclipse is now deprecated. It is no longer the officially supported IDE for FRC. VSCode supports Java and C++, as we would expect. It has many of the features you would expect from a modern IDE. Those would include stuff like Git integration, auto-completion, plugins, code linting, etc. It's free, cross-platform, lightweight. Yeah, it's a pretty nice application to work in. If you can't see the screenshot, like what's going on in that screenshot, don't worry about it, because I'm going to do a live walkthrough of VS Code in a few slides. So if you can't see what's going on, don't worry about it. Okay. Because we've migrated to a new IDE, WPILib had to develop a new plugin to migrate that functionality we had in Eclipse to a new platform. So we have all the features we used to have in Eclipse. That would include robot project creation with templates, those templates being command-based, timed robot, etc. We can also create commands, command groups, subsystems, PID subsystems, all from the plugin. We also have this thing called the command palette. This is a pretty big paradigm shift from what we had in Eclipse. So with Eclipse, all of your functionality relating to FRC was kind of scattered all over the place. So if you wanted to deploy code, you had to press that green button in the top of the screen to run as deploy. If you wanted to add a new library, basically what you had to do is add it to or download the jar from the company's website, add it to the class path. Now all the functionality relating to FRC is centralized in this thing called the command palette. So the command palette is basically, you can see that on the right-hand side, right-hand side. The command palette is a centralized location for all of our functionality relating to the VSCode plugin. Anything you want to do with FRC is in this one submenu now, so that's nice. Something else you can do from the command palette is you can manage your vendor libraries. So that's all done from the plugin now. You don't have to download the jar from the website, add it to the class path. It's all done from the command palette now. And something else that's in the command palette is that there's a tool for automated conversion from Eclipse projects to a VS Code project. So let's say you wrote something in 2018 that used Eclipse. WPILib, they thought about this, and then they designed a tool that allow you to convert a 2018 existing project to the 2019 system. So you have that interoperability between 2018 and 2019. Okay, so now I'm going to go into VS Code and actually show you what it is. Okay. Okay, so this is VS Code. On the left-hand side, we can see we have these 5 items. First thing is the tree, the Explorer. This is where you're going to see all your files represented in your project in this menu. Next, we have the search. So if you want to find something in your project, this is where you go. After that, we have our source control. So this is our Git integration in VS Code itself. This is where you push, commit, pull code from GitHub, etc. We have a debugger. We're not going to be really using that in FRC, but it's there if you want to play around with it. And then finally, this is where you manage your extensions. So this is where you get new extensions, delete extensions, etc. For the FRC problem space, we're probably going to be operating in 2 main things, the tree and then source control. We're not really going to be messing around with the other 3. Okay. So this is our command palette in the top right-hand corner, this little W, click on that. This is where you access all of your functionality. So you'll notice that like the first few of these are recently used. So when you first open VS Code, it'll look a little bit different than this because you haven't used it, so you don't have this recently used stuff here. Okay, so I'm going to walk you through creating a new project. So open the command palette, select create new project, a new project, like that. And it'll pop up this little GUI thing. Select what you want for the project. So template, we're using Java. And then for our purposes, let's say we want to make a command robot like that. Then we want to create a directory or select a directory where we want the project. So let's just say here. And then the project name, let's say TE session. Yeah, okay. And then we want to enter our team number, 6829, generate project. Open. Right. So this is our tree. This is where all the files we're working with are represented. So we want to go to source, Java, and here's our stuff. So if you use command-based before, this should look fairly familiar. We have our commands, subsystems, OI, robot map. Don't worry about main.java. That's new for this year, but you're not really going to be messing around with that very much. So let's go back to the command palette. This is where all the stuff that you want to do is centralized, all the functionality. So let's say you wanted to build your code. You would just simply press build code. If you want to deploy your code, you do that. Something that you're going to do very often for command-based is create a new command or create a new subsystem. The way you do this is very similar to the way we did it in Eclipse. So you find your directory, you right-click, you do create a new class/command, click that, and then it'll tell you, or it'll ask you what you want. So we did command directory, so we want to create a new command. You enter the name, you just do enter, and then it'll create a new command. And we can do that same thing for subsystems. So right-click subsystem, create a new class/command, subsystem, name. Okay, so we just made a new subsystem. So there's some other stuff you can do with the command palette. So I talked about that automatic conversion thing. So if you go here, see import and WPILib Eclipse project, click that, a GUI will pop up. You'll select your Eclipse project. Yep, so let's find a 2018 project like this. And then what you do is actually you import your build.properties file like that. It'll ask you for a file or a folder to place it in, and your team number and project name, and then you just do import. I'm not going to do it for this, but that's how you do it. So you just access the GUI and put in all the parameters that they want. So we don't have a RoboRio with us right now, but I can show you how to build code. It's simply go to the command palette, build robot code. So that'll build the code on the local machine, but it won't actually deploy to the RoboRio. You'll see in a few seconds that the build is successful. So I didn't actually deploy that to a RoboRio, but if I was doing that, I would simply go to command palette, deploy robot code, and that achieves that purpose. So new for 2019 is the vendor library support is very different, and it's much improved. So like I mentioned earlier, if you wanted to get a jar file for like the CTRE library, you'd have to go to the website, pull down the jar, add it to your class path. Now it's all integrated into the command palette. So what I do is I do manage vendor libraries, and then this is how you access and update your libraries. It's all done in the plugin now, and it's really convenient. So well, just the main takeaway from this is command palette. It's all command palette now. All the functionality is centralized. Once you get into 2019, you'll notice that you're doing most of your work in the command palette. Okay, let's go back to the presentation. Okay. Right. Okay. So in 2018, we used to manage our build process an Ant build script. The issue with this is that the Ant build script wasn't really exposed to the user. There wasn't really much you can do to change it or modify it or play around with it. It was for the most part static. You were constrained to those two fundamental steps, compiling and deploying. This was kind of constrictive. You couldn't inject those intermediate steps, those policy tasks and those administrative tasks. In 2019, it's different. We're using, instead of Ant, we're using Gradle to manage our build process, meaning that we can actually modify it. It's exposed to the user. We can inject those intermediate tasks in between deployment and compiling. So we can actually do those administrative tasks like sending an email, or those policy tasks like failing a build if the unit tests don't pass. You can do that in 2019 with Gradle. Something else about Gradle is that it's decoupled from the IDE, meaning that VSCode knows how to talk to Gradle, but Gradle basically knows nothing about VSCode or any other IDE that you're writing your code in. So this means one of two things. First off, you can actually use whatever IDE you want. You're not constrained to VSCode, but VSCode is the officially supported IDE for FRC for 2019. Second thing is that you can now deploy and do all your Gradle stuff from the command line or the terminal. If that's your thing, you can do that now. With Eclipse, you really didn't have that kind of freedom, so that's nice. Finally, I kind of covered this for the during the demo, but you can automatically fetch updated libraries if you're connected to the internet. So let's say you're using the CTRE library. If there's a new update that they release for the CTRE library, Gradle will automatically fetch that library, and then it'll manage it for you. So there's no need to like go to the website, download the jar, add it to the class path. It does it all automatically for you. If you're not connected to the internet, it'll just use the most recent version of the library that you have on your local machine. Okay. WPILib, there are some changes for the library. So if you don't know, WPILib is the standard library we use for FRC. First change is that we've migrated from Java 8 to Java 11. So make sure you have Java 11 installed on your machine when you start testing out these changes. Second thing is something called Pathweaver. So what Pathweaver is a motion profiling GUI. You have like a virtual representation of the field. You plot the points that you want to traverse. It'll generate a spline, like a path that you need to travel on. And it'll also spit out these motion profiling CSVs that you can use with the motion profiling framework. You can achieve that smooth and predictable motion with this application. For 2019, we have better support for unit testing from the WPILib library. We haven't really gotten around to testing that and using it, so I can't really talk about it at length. We also have something called, we have also limited simulation. So basically, from what I know from the WPILib developers, we can actually simulate like a simple robot, just a chassis, as well as like virtual joysticks. You can drive around a chassis on your computer instead of having to do it on an actual robot. Again, we haven't really gotten around to this, so I can't speak about it at length. Finally, we have, or the iterative template is now discouraged, highly discouraged. Instead, you should probably be using the timed robot instead of iterative. They accomplish the same purpose for the most part. So no longer use iterative, use timed robot. Okay. We have 2 new configuration tools. First off, the RoboRio web dashboard has been updated. So we have moved from Silverlight to HTML5. And the big implication here is that we no longer have to use Internet Explorer to configure our RoboRio. You can use any modern web browser, so Chrome, whatever. So that's nice. Second thing is that CTRE has released a new desktop application called the Phoenix Diagnostics client. This is where now we'll be doing all of our CAN bus work. So setting CAN IDs, setting your settings on the Talon SRX, that's all done from this application. So for the most part, all of our CAN functionality has been moved from the web dashboard to this thing called the Phoenix Diagnostics client. So mostly you'll be working with this instead of the web dashboard. Okay. Finally, we're going to end the presentation by discussing our 2019 experience. I'll tell you some tips that I want you to know, as well as some cool stuff we've been working on with 2019. So here's some tips. The installation files are quite large. So if you're using a flash drive, like if you're putting your installation files on a flash drive and then passing those flash drives around to each person to install on their laptop, make sure, first off, that it's a large enough flash drive, and second off, that the flash drive is formatted to something that can accommodate 4 gig files or greater. So not FAT32, but FAT32X or NTFS. That's actually something we ran into. We had like a fairly large flash drive, but we couldn't actually put the files on there because our thing wasn't formatted to the correct format. Also, the actual installs, like when you install them on your laptop, they can take up quite a lot of disk space. So when you're doing that, make sure that you have sufficient disk space on your laptop. One of our programmers' laptops didn't actually have enough disk space when they were installing, and that actually caused the install to fail. So just keep that in mind. The installation times, they can take very long. They take a few hours typically. So just make sure you're planning ahead. Keep that in mind when you're running through this transition process. We also recommend removing any FRC-related software from 2018 and prior. That would include Eclipse, CTRE, the NavX software, etc. When you run the WPILib installer for 2019, it'll give you an option of installing their version of VSCode. I would recommend doing that instead of installing the plugin on top of an existing installation of VSCode. It's important to note that you can actually install this special version of VSCode alongside a normal installation. So there's no need to uninstall an existing version of VSCode when you install the special WPILib version. They can exist independently of each other. Okay, finally, there's some stuff we've been working on during the off-season that is made possible by the changes in 2019, specifically Gradle. Something we're working on is implementing better code traceability for our development process. So the reason we did this is because we had an experience in 2018 during the state competition where we pushed or deployed a defective change to the robot that caused some major issues. So we reverted back to a safe version of the code, but the issue was we never actually pushed that defective code to a local repository or to GitHub or anything, so we lost that forever. We weren't able to go back and check why that code was defective in the first place, what caused the issue, why didn't it work, so we couldn't diagnose the issue like we wanted to. So because of this, we wanted to implement some improved code traceability. So now whenever we go to competition, we have in our build script, whenever you deploy to the robot, it'll automatically commit to our local repository in Git. That means that every deploy has a Git ID, and we also deploy that Git ID on shuffleboard. So whenever we connect to the robot, we know what version of the code is on the robot at any point in time, because it'll have that Git ID that is associated with any deploy. This also gives Drive Team confidence about robot behavior, because they can know that programmers haven't actually changed anything on the robot regarding to programming, because they have that Git ID. So we can go back to our Git history and correspond that Git ID on the shuffleboard to whatever version of the robot code we have. Second thing we're working on is unit testing. So last year, we wanted to do unit testing in FRC. The issue was that the library really didn't have the support. It wasn't mature enough, so we couldn't really do it. This year, WPILib is working on much better support for unit testing. So, in addition to that, we have a more exposed build process. So something we're looking at is modifying our build process to implement those policy changes that I talked about. So we have unit tests, and if those unit tests fail, then we don't pass the build, and the code won't deploy to the robot. So implementing unit tests with our build process is something we're working on for 2019. Okay, we need your feedback. This presentation was made in part by certain organizations that like to know how our outreach is impacting the community. Because of this, we need your feedback to determine what kind of demographics we're impacting, how many people we're impacting. So if you can, please go to that link, fill out the survey. The class is 2019 Control System Preview. I'll give you a second to take down that URL. Okay. All right, so that's the presentation. Thank you to everybody who showed up. Thank you to Georgia First and the RoboJackets for hosting the presentation. Yep, and now we're gonna open up to questions if anybody has any.
Can we see the new UIs and the new stuff actually implemented in your Visual Studio stuff?
What do you mean?
Which one are you asking about?
I just want to see the cross-field ones and potential unit testing that you implemented.
So, you can show them the code.
Sure.
We have 2018 code. We haven't implemented it. We don't have RoboRio, so, and sadly, my driver station, my laptop is bored. It don't run right now. Yes.
Okay, so we have this class in our robot project. It has all of the information we want that relates to code traceability. So you can see here our get ID and all that stuff. So basically the way it works is that we have in our build script or build.gradle, we have some functionality that'll update this class, the information in this class every time we deploy. And then we pull this information in this class and we display that on Smart Dashboard. So I don't have a RoboRio on me to like demonstrate what happens, but whenever we deploy, it'll see that we deployed, it'll update the get ID, and then it'll display that updated ID on the Smart Dashboard. So we know what code is running on the robot at any time.
Code.
For
Shows the 2018 code.
2018. Okay.
How is our code unit testable?
Okay. So, all right. So last year we made some changes to the framework that's a little bit different from what FRC does by default. So I can show you that. Okay. So typically the way that you do code in FRC for like hardware objects or something like that is you instantiate those hardware objects in the robot map, and then you import the robot map into your subsystem, and then you reference them globally. So you have like public Talon SRX in the robot map, and then you reference those in your subsystem. We did stuff a little bit differently. So we instantiated our hardware in the subsystem itself as a private instance variable, and then you can see in our constructor, we pass in the CAN IDs for those hardware objects. This is a little bit different than what FRC wants you to do, but the reason we did this is because it facilitates improved unit testing. So in our constructor for drivetrain, we have all our CAN IDs, and then in robot.java, we scroll down here, we will actually pass in all of those CAN IDs in this method, initialize all. We call initialize all when we initialize the robot. So you can see here, we instantiate the drivetrain with all those parameters. Like, yeah, you can see that. And this is what we do essentially for all of our subsystems. So we have our dumper, instantiate here, pass in the parameter, shooter, intake, all of our intake stuff. Basically everything we want to do for subsystems, we pass in the parameters rather than referencing them globally in the robot map. We did this in part to facilitate much better unit testing, or to improve compatibility with unit testing if we ever got it. So, Okay. So one thing we wanted to do with in 2018 is, for example, we wanted to square the inputs on our joysticks. So what we did is we wrote an interface for any generic transform. So we have iTransform here. All that is just a method that takes in a double for an input. And we actually, for example, squared input transform, we implement iTransform, and then we actually do what we want with the transform. So if we're squaring it, we simply want to return the value times itself and copy the sign. And then we actually have unit tests for those transforms. So for example, we use JUnit here for a squared input transform. So we have the test cases here. So 0, 0 squared is 0, so that's what it should return. Yeah, and then we also want to copy the sign. So 1 squared is 1, obviously, but we also want to copy the sign, so it's still -1. 0.25 squared is 0.5, or no, sorry, 0.5 squared is 2.25, and you can see we have all the test cases here. We're using JUnit for this. So basically what happens is we instantiate an instance of our squared input transform, and we test that. So we pass in all these test values here, and we make sure that the transform actually works as intended. So this is a very simple example of a unit test we use simply for the transforms. In 2019, we're hoping that we have better function or better support for actual unit tests. So like we can unit test our subsystems, our commands, etc. We're hoping that we can go beyond simple like testing of a transform class. Yeah.
Can you show them how that's then used in the command and subsystems?
Sure. So we can go back to our drivetrain class. Don't worry about all the red. We haven't imported all of our libraries yet, so.
Why don't you start at robot.java?
Where is it? Okay. So
209, 210.
oh, there it is. Okay. So basically, give me a sec. All right, so we create a new instance of a transform. So if you scroll up here, all the way up, you can see we have iTransform and then arcade drive transform. So we declare that up here, top of the class, and then in initialize all. What we do is we instantiate arcade drive transform as a squared input transform. So we have that now. And then what we do is we pass that in to arcade drive, which is a command. So as you can see here, we pass that in as a transform, as a parameter. And then if we go to arcade drive, let's see, arcade drive. So you can see here that's a parameter in our constructor. And then what we do with squared transform is in execute. We simply pass all of our joystick inputs through that transform so that we get squared inputs. Yeah. And then, yeah. So we have a method in drivetrain called arcade drive. We take that squared transform that we passed in through the constructor, and we place it in this method, arcade drive. Yeah. So that accepts an iTransform as well. We use that. Yeah, so we use that here. So throttle power, we take that, pass that to the transform. That'll square our inputs for us. Yeah. So that is how we did, or that's how we partially implemented unit testing in 2018. We're hoping next year we can do a little bit more with unit testing, specifically unit testing subsystems and commands rather than just transforms. So, yeah. So, do we have any questions regarding? Yep.
Could you show us how you implemented PathWeaver program in
So we didn't actually, so PathWeaver didn't exist in 2018, so we weren't actually able to implement that in our last year's code. But we did use something very similar to PathWeaver. It was a third-party GUI that we used to generate those motion profiling CSVs. So I can't really show you PathWeaver at the moment.
You show us how you did it with the third party?
It's on,
Did you guys use motion profiling last year?
Yes.
Which framework did you use? Okay. I don't have that installed on mine.
No.
The pathway is not on my machine?
No.
Do
Um,
you know how you would implement a PathWeaver?
So-
Well,
Okay. So let's say this is our field. It's a rectangle. Here we have like the switch, and then let's say this is the scale. We start here. That's our robot, this little thing. So let's say we want to get the right side or the middle of the field to drop off a like cube in the scale. So that's our end position here. And to get from here to here, we want to like insert some kind of intermediate waypoint so we have like a smooth path. So let's say we want to go here, then here, then here. Basically what PathWeaver will do is in this GUI, it'll interpolate a curve to traverse from where you start to where you end, and it'll also respect these intermediate points. So basically it'll look something like that. So it'll generate that spline for you. And once you're satisfied with the spline or the curve, basically you export a CSV file. And basically what the CSV file contains is for every time step from where you begin to where you end, you'll have your the heading that you need to be at, the velocity, the XY position, as well as your angular velocity. So that way you have that CSV file and you can feed it back into the motion profiling framework of your choosing. So whether that's Pathfinder or your own custom framework, it'll accept that CSV and you'll be able to traverse this path smoothly and reliably. Yeah. So
other than the points, what settings do you give that?
So in addition to the points, you can also specify a maximum acceleration and a maximum velocity. PathWeaver or Pathfinder or any other motion profiling framework will obey those constraints. You'll never exceed that maximum velocity or maximum acceleration for the most part. So that's what allows you to achieve that smooth, consistent motion. Yes.
Can you set the start and end angles as well?
Yeah. So any of these waypoints, you can specify your theta, your angle. So if I wanted to be like 90 degrees here, I could do that. Yeah. Any more questions?
Have you ever run into a problem where you're deploying code through Gradle and then it says it's deployed, but the code hasn't actually changed on the RoboRio?
I can't say we have ran into that issue, personally. Can you like give some more specific?
Along with the commit ID, there's also a timestamp.
Yeah.
Why don't you something like that?
What other stuff besides square transform do you want to unit test?
So something we're looking at is unit testing our subsystems and commands. So making sure that when we pass in like an input to a command or something, that it spits out the correct output. So let's say that we have like a command that goes forward X amount of distance. So let's say you pass in 5 feet for that command. We want to make sure that what it outputs is like the correct number of encoder ticks, for example. So let's say we pass in 5 feet, and then the output should be X number of ticks. So that's something we're looking into, making sure all of our commands, given an input, will have the respective output.
Is there anything you made in 2019?
Personally, I didn't have any issues, but I know a lot of our team members had a lot of issues with the installation process specifically, so I can talk about that. So one person, they didn't have enough disk space on their hard drive, so the install failed. Some of the installs just took really, really long, so like up to 3 hours. That was annoying. One of our developers uses Mac OS, and that at the moment is completely unsupported, so his install failed. That's him right there. Another for programmers, like theirs just didn't work for some reason. Like they had to do it multiple times.
That's for a beta.
This is beta, so keep in mind that many of these issues will be resolved probably. Flashing the RoboRio was problematic as well. So the first time we tried to flash it, it failed. Second time it worked, so that was kind of annoying. Most of these issues will be resolved by the time that the software is released for the 2019 season, so don't worry about it.
What are you most looking forward to?
Probably being able to modify our build process this year with those administrative and policy tasks. So like, if our unit tests don't pass, don't deploy to the code, or don't deploy to the robot, because you don't want broken code on the robot, obviously. So that's something we're looking into. Yeah.
We've run into issues when using Gradle, when we try to deploy to RoboRio, it doesn't manage to find the RoboRio even though we are connected to the network. So
Are you on the alpha version of the plugin?
I think we're like 2018.3.
So,
Wait.
all right, so we can't be in the beta.
Yes. Wait. So I have a question. So are you using VSCode?
No, we're using Intelligent. Yeah.
But you're using. So are you using Gradle Rio or are you using the actual like?
RoboRio.
Okay. And you're using like, not the FRC Gradle Rio. You're using the other Gradle Rio, like the one developed by Jassy. You're using that one, or using the official Gradle Rio?
I think
The official one. And so what's the issue again?
So when we try to deploy to the robot, we're connected to the RoboRio.
Mhm.
But when we try to deploy it, it says that there's no RoboRio found.
How are you connected to the robot? Is it like Wi-Fi or USB?
Wi-Fi, yeah.
Wi-Fi?
And when we open the, driver station, it does manage to connect. It says it's connected to it.
So you have comms, but you just can't deploy code?
Yes.
Same problem over if you're not trying to connect to the robot via Wi-Fi, do you still have that problem?
Yes.
I personally had it a couple of times, and it was just like a timeout kind of thing. Like it's searching for the Rio, and the Rio doesn't respond in the amount of time that Gradle allows for the communications to be handled, and so it failed. And then I just run it again, and it would succeed usually. Like that, I saw that personally a couple of times.
So,
But that was with the alpha.
so when you deploy to the RoboRio and you deploy from Gradle, do you see like a red message saying build failed, something like that? Or does it just not start at all?
No, it does start, but it says the build failed. No, it does. The build is successful, but when it says discover RoboRio, it fails.
Hmm.
All right, I'm gonna ask that. Did you reboot?
Yes.
Does it connect immediately?
Yes.
Does it always connect immediately after reboot?
Like, you mean to the internet? Yeah.
Oh, well, when you try to deploy and I can't find it, and you reboot, does reboot always fix it?
No, sometimes it never works, even when we reboot.
So it's kind of hard to answer your question without seeing like specifically what your configuration is. Yeah. If you have like a laptop on you that you have your stuff, and if I take a look at it, I can maybe diagnose the issue. But it's kind of hard to say like what exactly is wrong without looking at the machine. So.
You could install Wireshark and then do a packet capture and then go back and see if it's responding or not. It's one thing like that.
Have you tried like pinging the robot from,
Yes.
and they talk to each other?
Yes, I believe.
That's interesting. Yep.
Do you guys have any plans right now for how to introduce new teams to 2019? Because there's probably some leads, or even first or second year teams that just learned how to do stuff in 2018,
Mhm.
but they don't know how to incorporate the stuff from 2019 yet. Have you guys, in your outreach as a team, planned for that at all?
Actually, Rob was there. We actually did basically a FRC 101 class for people that just new to FRC, and we used the alpha as that. If somebody's got questions, reach out to Tyler, and we can definitely field them or give us some assistance. That was a 4-week, 2-hour night, sort of like, how do you go from I have no idea till a drivetrain moving?
That was very good. Have you found yourself like looking at a lot of the Java features that were introduced
incorporating those, or have you not really played around with that?
We haven't really played around with the Java 11 features. I took a glance at them. The changes that were implemented in Java 11, they're not really relevant to FRC in my opinion. They kind of go beyond what we do as an FRC team, so not really. Any more? Okay.
Thanks, Tyler. I'm Sarah Storr, and this is the RoboJacket space. So thanks to Ignite Robotics and Tyler Shen for presenting on the 2019 control system. So, yay. This is the last TE session of the year, so thank you for coming. I really appreciate you guys who have stuck with us throughout the whole thing. All of the sessions are online at robojackets.org/TE-sessions, as well as our YouTube and our Twitch channel, which is where you guys are seeing this now, on the internet. But yeah, cool, awesome, yay, see you next year.